In this video, we're going to talk about how to treat radical equations. And we use the important rule that if a and b are real numbers and n is a positive integer, then if a equals b, then a to the n equals b to the n. So we're going to be using the method isolate, square, check. And all you have to do with this method is isolate the square root, then square both sides. And our rule tells us that if we square both sides, we don't have to worry about losing the possible answer. If there is an answer, we should get it. If there's not an answer, we might get a red herring, so we do have to check when we're done. We're doing isolate, square, then check your answer. So in this case, we already have our square root isolated, so we can start by just squaring both sides. On the left-hand side, the square root and the square go away. On the right-hand side, 3 square is 9. 9 equals 2x minus 1. Add 1 to both sides. 2x equals 10. Divide by 2, and x equals 5. Now, if we plug that in, it should make sense. So our original equation is right here, so plugging it in would give us the square root of 2 times 5 minus 1 equals 3. Or the square root of 10 minus 1, 9, equals 3. And it does, and we're good, so we are correct. X equals 5. This next one is very similar, so take a minute and see if you can get an answer. Once again, we already have the square root symbol isolated, so we just square both sides. Square that, square that. And I have 2x minus 5 equals 49. Add 5. And we get 2x equals 49 plus 5 is 54. Divide by 2, and x equals 27. Now, if we check our answer again, we get the square root of 2 times 27 minus 5 equals 7, or the square root of 54 minus 5 equals 7, or the square root of 49 equals 7, which is true and makes sense. So now let's try one that might not make sense. This time we have a similar problem, but we have a negative sign on the right side. Let's see what happens. I can still square both sides, and in doing so I get 3a plus 4 equals negative 4 times negative 4 is positive 16. Subtract 4 from both sides, and I get 3a equals 16 minus 4 is 12. Divide by 3, and a equals 4. It seems like we don't have a problem, but what happens if we plug this 4 in? We get the square root of 3 times 4 plus 4 equals negative 4. Or the square root of 3 times 4 is 12 plus 4 equals negative 4. The square root of 16 equals negative 4. But we know the square root of 16, the principal root of 16, is going to equal 4, not negative 4. So this equation actually doesn't have a solution for us. This is not going to give us a good enough solution to keep. Now here's where that first isolate comes in. In this one, squaring both sides right away would result in still having a square root. So we're going to have to isolate the square root m by subtracting 2 from both sides. We get root m equals m minus 2. Now if I square both sides, square that, I get m equals m minus 2 times m minus 2. A quick FOIL will tell me this is equal to m squared minus 4m plus 4. Now I have a power here, I have a square here, so I know I'm going to need to factor this trinomial, so I'll subtract m from both sides and get 0 equals m squared minus 5m plus 4. Factoring, I need two things that multiply together to equal 4, but add together to equal negative 5. Those two things are just m minus 4 and m minus 1 equals 0. So our two possible solutions here are m equals 4 and m equals 1. Let's check to see if they're both correct. If I plug in m equals 4, I get the square root of 4 plus 2 equals 4, or 2 plus 2 equals 4. So that one checks out. This is definitely a good answer. And if I plug in 1, I get the square root of 1 plus 2 equals 1. The square root of 1 is equal to 1. 1 plus 2 is 3. 3 is not equal to 1. So our only solution here is actually going to be m equals 4. Moving on, we have another one very similar. Take a minute and try it. Once again, I'll subtract 6 from both sides. I get square root of y equals y minus 6. Square both sides, square that, and I get y is equal to y squared minus 12y plus 36. I'm going to have to factor again. Subtract y, 0 equals y squared minus 13y plus 36. Now I'm going to need two factors of 36 that add together to give me 13. And I immediately see that 9 times 4. 9 and 4 is 13. So we get x minus 9, x minus 4. So our two possible solutions are x equals 9 and x equals 4. Let's see if they both work this time. Square root of y plus 6 equals y. Square root of y plus 6 equals y. Let me just make sure I'm correct there. Yep. And if I plug in 9, I get root 9 plus 6 equals 9. Square root of 9 is 3 plus 6 equals 9. That one checks out. If I plug in 4, I get the square root of 4 plus 6 equals 4, or 2 plus 6 equals 4, which is not true. So 9 is the correct answer. 4 is not a correct answer. So when you are trying to solve an equation that has radicals in it, you should always remember the isolate, square, solve, then check method.